Hi geometry students, in this video we're going to take a look at 8.3 notes. This is similar triangles. Specifically we're going to look at something called angle-angle similarity. So you got a warm-up problem here. Ideally I'd like you to actually try the problem before you listen to the solution, so it won't hurt to pause the video and see if you can figure it out. So what this problem is all about, saying, is triangle LMN similar to triangle ABC? And if you think so, figure out the scale factor from ABC to LMN. All right, so one of the things you should look for when you're trying to decide if different polygons are similar is angles. You want their angles to match. So if you look at L, you look at A, those are just have one arc, so they're going to be the same measurement. Same thing with B and M. And kind of think through this scenario. If you got two angles of one triangle matching two angles of the other triangle, both the triangles have to add up to 180 degrees. That means that last set of angles in each of the triangles is going to have to be the same. We talked about this in the first semester in geometry. That was called third angles theorem. That might ring a bell. But anyway, so all my angles are matching each other. Next thing I'm going to check is the sides. Excuse me. And they asked us to do a scale factor from ABC to LMN. So if I pick on like the smallest side in ABC and the smallest side over here, now we're moved on to sides. I'm going to do 3 is to 2.25. Now that might be kind of hard to work with, so don't be afraid to use your calculator to help you with that. So if we do 3, hold on one second, let me see if I can get this calculator to work here. 3 divided by 2.25. We hit enter. It gives this to us back as a decimal. But if you go to the math button, and then you go, the first one is fraction. It's going to change it, and it says, hey, it's 4/3. So this is the same thing as 4/3. Then we just keep working our way around our shape. I'm going to try like the 7, so that's like the medium length, and 5.25, that's medium length. So we'll do 7 over 5.25. Do the same thing where you come in here, take 7 divided by 5.25. And then hit math, fraction, yep, enter, enter, we get 4/3. We'll do green next. My last one would be 9 over 6.75. We'll try that out. 9 divided by 6.75. Yep, we're getting that same 1.3 repeating number. So yeah, it looks good. All of these are the same. That's the same as that, is the same as that. So all my sides are matching. And so yes, these are similar. And then my scale factor is going to be 4 to 3, like that. You can also write it in like a fraction format if you wanted to. So either of those is totally fine. All right, so that's our warm-up problem. But that leads us into this question here. It says, what do we need to know to decide if two triangles are similar to each other? So essentially, we already worked this out. Hold on one second. I'm trying to get different colors, but apparently it's not going to let me. Okay, so the things we need to know that we have our angles matching, so we need to have congruent, they have to be the same measure, congruent corresponding, so in the same spot, corresponding angles, and then we also need to have corresponding sides proportional. It just means they give the same ratio, like the 4/3 that we were talking about. So that's what we think we need. We need all that information. But there are shortcuts, just like there was shortcuts when we talked about congruent triangles. So here's one of the shortcuts. This is kind of the focus of today, is saying that actually if you just know information about two of the angles, angle, that's enough to say the two triangles are similar. You wouldn't have to know anything about the sides. You wouldn't have to check for the scale factor. You wouldn't have to know the third angle. The third angle is going to have to be the same. And so that's enough to say, hey, two triangles are similar to each other. I think this would be good for you guys to put on your reasons list, which was a gray sheet of paper. We were writing down a bunch of reasons last semester. If you don't have a reasons list, I can get you one when I get back to school. So don't freak out about that too much. But if you do have your reasons list, get that written on there. Okay, so again, this is a shortcut. If you see two angles that are the same, it's good to go. So then it goes in and asks us, hey, are these triangles similar or not? Well, I've got 45 and a 45. And the other thing that I have in this picture that I hope you recognize is from these intersecting lines here. When you got the triangles nose to nose, there's actually vertical angles there. Vertical angles. So are the triangles similar? We're going to say yes, because we have two sets of angles that work. So by angle, angle, similarity. So you can do that little shortcut like that. Check out the next one. We've got 70 and 70. That's looking good. Now this one's 30 and this one's 85. We could find the missing angles, like find this one here by taking 180 minus 70 minus 85. See what's left over. 25 degrees. And do the same thing up here. So 180 minus 30 minus 70. And that gives us 80. But already those aren't matching each other. All the angles need to match. So we probably didn't necessarily need to go through all that work. This one's going to be a no-go. Angles aren't congruent. Okay, next up, we've got a 90-degree angle. We've got another 90 degree. We got a 44 and a 47. Now I can figure out this angle, kind of like what I did in the last one, to 180 minus 90 minus 44. That's going to land me at 46. And then likewise here, 180 minus 90 minus 47. And that's going to land me at 43 degrees. But right away I knew that this wasn't going to work out. I mean, we had our 90-degree angles that were good. But because 44 is not matching 47, kind of like the last problem, we're going to say no, angles aren't congruent. Okay, next problem. It says Aaron, who is 1.6 meters tall, casts a shadow that is 1.25 meters long. And her shadow extends to the end of a tree shadow, where she stands 4.75 meters from the tree. What is the height of the tree, and draw a picture to go along with the scenario? All right, so let's do that. We're going to have a tree. Something like that. Then we have a shadow going on. And somewhere along here, there is a person named Aaron hanging out. Get some hair. Okay, and they have a shadow. And their shadow is like this part right here, but extends to the end of the tree shadow. And then what's happening is we've got this right triangle. We're actually going to go out a little ways here. Didn't quite go as far as I wanted it to. Extend this side as well. Okay, so there's the scenario. There's a right triangle here. Maybe I'll split this up in just a second. But some of the other information, we've got the height for the person, 1.6 meters. We have cast a shadow that is 1.25 meters long. She is 4.75 meters from the tree. What is the height of the tree? Whew. Okay. So there is a very large right triangle there. So there's that angle. You're trying to find the height. And that whole bottom length is found if you take 4.75 plus 1.25. That gives you 6. Then you have a smaller triangle over by Aaron, like this one over here. And that's 1.6 and 1.25. Now, notice you have your right triangles, right? Your right angles. And then they actually also share this angle down here in the corner. So this angle and that angle are the same. And so you have similar triangles by angle similarity. And our goal is to figure out what h is. So we're just going to use a proportion, kind of like what we were doing yesterday. So you're going to do h over 1.6. And we're going to set that equal to 6 over 1.25. So cross multiply, you get 1.25h equals 6 times 1.6. We'll divide by 1.25. And you'll get 7.68 meters for the height of your tree. Hopefully you followed that. Okay, let's do another problem kind of like this one. They got a pole, it's 12 feet tall. You can see that kind of in the middle of your picture. It's used to support a guy wire from a tower, which runs from the tower to a metal stake in the ground. After placing the pole, Travis measures the distance from the pole to the stake and from the pole to the tower as shown in the picture. Find the length of the guy wire. So you're trying to figure out this whole thing right there. That's our unknown, that's x. Kind of like in the tree problem, there's two triangles. There's a very large triangle. That's the one where you're trying to find the length of the guy wire. There's going to be an angle down there, 90 degrees. And then that whole bottom, if you do 23 plus 5, you get 28. And then there's a smaller right triangle. Grab that one. This is 12, this is 5. And then because they both have right angles, and they both share this angle right here, these triangles are similar by angle similarity, which allows us to see if we can figure out what this x is by using proportions. The sides have a scale factor to them. They have a ratio. Now, if I put x over, I'd have to know what goes in this spot, but I don't see anything there. So I'm going to have to work on that. If I come back to this shape, I've got 28 over 5. Now I can find that missing piece by using the Pythagorean theorem. So I'm going to do 5 squared plus 12 squared equals c squared. This is 25 plus 144, which is 169. And then we'll take the square root and we get 13 out. So we'll multiply on the diagonals. This is 5x equals 13 times 28. Get some bigger numbers here. This is 364. We'll divide by 5. And so you'll get 72.8. And this is going to be in feet for the length of that wire. Okay, let's see what else we got going on for us. Number 6 says find the value of x in the pair of similar triangles. Alright. So as I'm looking at this, I'm trying to figure out how I'm going to set up my proportion. If they're similar, I can do proportional sides. So I'm going to pick on where the variable is located at. I'm going to write that down first. 20x minus 3. And that's in this triangle. So I want to move to the other triangle. I just have to figure out which side corresponds with TV. So TV goes along with TF. And TF is there, so that's going to be 42. Now I have to go back to the green triangle, grab the 132. And then we'll put that over 72. And then we'll go through and we'll cross multiply. We just got some big numbers here. So we'll do 72 times the quantity 20x minus 3. And we'll set that equal to 42 times 132. And distribute through. This is 1,440. This is 216. This is 5,544. Oop, I dropped my x. We'll add the 216 over. Oop, sorry, that got really sloppy. We'll divide by 1440. And you get 4 out for an answer. Okay, last one. So you have two triangles, kind of like the other two problems here and here, where you have like one triangle's embedded in the other triangle. I'm really focusing on this right here. I see that's that side of the smaller triangle. So I'll do x plus 22. And then I'm going to put that over the larger triangle side that corresponds over 45. Then we'll head to the other side. You got 52. That goes along with the smaller triangle. All over 65. And then we'll cross multiply through that. And we'll distribute. And you get 14 out for your length there. Alright, I believe that's the end of our notes. Yeah. Okay, so thanks for watching notes on 8-3. I hope you guys have a great day.